Okay, so week's one video is about classification of differential equations, order linearity, and the integrating factor method. So to start off with some keywords, the keywords I listed was homogeneous, non-homogeneous. Those are to classify different types of linear equations, order, and derivative. So to start, the order of a differential equation is the highest derivative present. And I'll show you examples of those later. And also to prove the linearity of a differential equation, a homogeneous equation is when all dependent variables are collected on the one side of the equation and the other side is equal to 0. And if it's non-homogeneous, then that is when it is not present. So these are a couple of examples of differential equations that we need to classify. So this first one is first order because the derivative is the highest derivative present is to the first derivative. And it's non-homogeneous because the opposite side of the equation is not equal to 0. And then for this third one over here, it's also first order, but it is non-linear because the derivative is being multiplied to the fourth power. So if there's an operator on the derivative, then it's no longer linear. And this last one is an example of a third order differential equation because the highest derivative present is to the third order. And going down to explain the integrating factor method. So pretty much the first thing you want to do is put the equation into standard form. And then once the equation is in standard form, you want to find mu, which is your integrating factor. In the equation to find mu, it's e to the integral of pt dt, and pt is the function by the y in standard form. Then once you get mu, you multiply mu on both sides of the equation, and you should see that it gives you the product rule, which we learned back in Calculus 1. And after you see that it gives you the product rule, you can take the integral of both sides. And then at the end, you solve for y. And that is how you solve the equation using the integrating factor method. And this is the same method I used for number 6 when solving. So at first, I put the equation in standard form. So you had y prime plus 1 over ty equals sine of t. And then right here is what you have your p of t. So you would use that to find mu, which is your integrating factor right here. And then after you find mu, which was t in this case, you multiply t on both sides. And then you recognize that that is the product rule. And then once you integrate on both sides, you have t of y equals cosine of t plus c. And then after you solve for y, your final equation or your general solution is going to be y equals cosine of t over t plus c of t. And because there are initial values in number 6, you would plug in pi over 2 for t and plug in 1 for y in your general solution. And then after you plug these values in, you end up getting c equal to pi over 2. So you would just plug in that pi over 2 into the general solution that you found earlier. And your solution after using the initial values would now be y equals cosine of t over t plus pi over 2 of t. So yeah, that is pretty much the integrating factor method and order linearity that we learned in the first week of class today. Thank you.